Welcome to Matematika. Today we're going to do the rates of change in quadratic functions. In my previous video, we did the rate of change in linear functions. So this time we'll do the quadratic functions. So unlike linear functions, which have a constant rate of change, the rate of change in quadratic functions are non-constant, meaning that they vary depending on the input values. So let's look at it, how it goes if you are given a table like this. First of all, it says to determine the value by which a quadratic function increases or decreases, get the first difference of the y values. So our f of x here is the y values, all right? And the x are the x values. So let's look at the y values right here. So 9410149. All right, I start. The difference between 9 and 4, that means 4 minus 9, you have a negative 5, right? Between 4 and 1, meaning 1 minus 4, you have a difference of negative 3. Then 0 minus 1, you have a difference of negative 1. 1 minus 0, that's 1. 4 minus 1, that is 3. Then 9 minus 4, you have 5. Okay, so that is your first difference, which is the difference between the two consecutive y values, meaning consecutive, meaning the value that comes one after another. All right. The second is we have to find the second difference. So this is our first difference. So our first difference is negative 5, negative 3, negative 1, 1, 3, and 5. All right. In the first difference, what can we say about it? What can we say with the values? These values are what? Let's find out. Let's do the second difference. Okay. Let's do the second difference this time. We have a negative 3 minus a negative 5. That would become negative 3 plus 5. That is 2. Then you have a negative 1 minus a negative 3, or negative 1 plus 3. That is 2. Then you have 1 minus a negative 1. That means 1 plus 1. You have 2. 3 minus 1. You have a difference 2. And then 5 minus 3. You have 2. A difference of 2. Now 2 here is our second difference. Okay? So by looking at the values, these values are increasing by 2. All right? Are increasing by 2 each time. And then, so the second difference has a constant what? What can you say about the second difference? It has a value of 2. And it is constant. rate of 2. All right. What's the difference between its linear? In linear, the first time we get the difference, we get the constant rate of change right away. But in quadratic function, on the first difference, you have a non-constant, meaning they vary depending on that input values, but you have to get the second difference, okay, in order for us to get a non-zero constant. The second difference is a non-zero constant. Then it will be the value. The value should be a constant value, constant rate. All right, in this case, our constant rate is 2. All right. So notice when the value is increasing by 2 each time, this means that the second difference has a constant value of 2. Okay. Now, how about you are given a graph? If we look at this table, if we try to get the function, we could have function of y would be x squared, right? Because you have here a negative 3. When you square that, it gives you 9. A negative 2, when you square that, it gives you 4. And so on. So that means your function here is y equals x squared. So when you look at this and try to have this in a graph, plot these points in a graph, notice, okay, let's have the graph right here. Notice that for equal x interval, the y value is increased by 2. 2 more for each unit increase in x when x is greater than 0. So we come up, if you can see here, it's facing up. And this, we come up with a parabola. I hope you remember this in your Algebra 2. We'll be doing more on this later. Okay. So what does it mean? For example, I will get some values here. Let's say, all right, the first one is negative 3. We have 9. Then we have negative 2. Then the output is 4. Then we have a negative 1. That's 1. Then 0, 0. Then 1, 1. When x is 2, y is 4. When x is 3, y is 9. If you can see this, on the left side is the mirror of the right side, right? Whatever values you have or whatever points you have on the left, it's the same point on the right, regardless of the sign, okay? The left side, of course, they have the value of the output, which are negative, and on the right side, the value of the input on the left side is negative, and the value of the input on the right side is positive. Okay? So the graph here form a parabola. So what have we noticed? 1 over 1, then you have 1, 2, 3 over 1, then 1, 2, 3, 4, 5 over 1. All right? So for equal x interval, the y value increased by 2. Okay, so if my x interval is 1, the y increased by 2. 1, 2, 3. From 1, it becomes 3. From 3, it becomes 5. Look at the interval here for the y values. So, when it's 1, it is 1. Okay? When it is 2, it is 3. This is the input. The output. Okay? When it's 3, it is 9 on the right side. So that means that x is increased by, this is 5. That's the y value. This one right here. I'm talking about this. I will regard this y value. Increase by 2. Okay? So the equal value of x interval. So for every value of x intervals, the y values increase by 2. 2 more for each unit. Same thing with the left side. Oh. Every time we increase in x. Okay, same thing here. We have an increase, we have 1, and then plus 2, we have increase of 3, and 3 plus 2, we have increase of, we have 5. We increase by 2. Okay. So when x, this is when x is greater or equal to 0. Okay, let's look at this in the side of, having an example. The more we understand. Example. Find the average rate of change for a quadratic function. By looking at the function class, sorry for that, I always say class. By looking at the function for the quadratic function, we know that it's quadratic because the x has an exponent of 2. Okay? For linear, the x is to the power of, first power. Okay? To the degree of 1. Here we have a quadratic function, y equals x squared minus 2x on the given interval. Okay. So, the interval is 1 to 2. Okay. So, if we write that in terms of close interval 1 to 2. All right. So, let's look for 1. 1 is right here. Where does it touch the graph? Right here. For 2, it touches the graph here. Right? So that means our average rate of change will be it rise 1 and run 1. So the rate of change is 1. Rise over run. Right? When you have a graph, you can use the rise over run for slope. Rate of change. Right? 2 to 3, we can write that as a close interval between from 2 to 3. Okay, so let's look at 2. 2, it touches here on the graph. When it's 3, where does it touch on the graph? Here. All right. So with that interval, we run 1 and we rise 3. Okay, this is 3, this is 1. Here, this is 1, this is 1. So that means rise over run, just use the rise over run. It rise 3, run 1, so the rate of change is 3. Simple. When you have a graph, it's easy for you to see. 3 between 3 to 2, 3 to 4. So our interval there is 3, 4. All right, let's look at 3. Right here, I will blow this up. So this is 3, go up to the curve, right there. And then let's look for 4. Go up to the curve right here. So from these 2 points right here, it ran 1. And how much did it rise? 1, 2, 3, 4, 5. Okay? So rise over run 5 over 1 or equals to 5. That's the rate of change. All right? How about if you are given an interval? Of course, there is no graph, so you need the function. The function given is y equals x squared minus 2x. By using the intervals, what happens when your function is at 4 and when it's at 5? Okay, let's do this. 4 squared minus 2 times 4. We substitute the value, the input value. So that will be 16 minus 8. You have 8. Right? In 5, you have 5 squared minus 2 times 5. So you have 25 minus 10. And that is 15. Okay? So doing like finding the rate of change, remember? y2 minus y1. So this will be our x1, x2, wait. Sorry for that. Oh. This is interval of 4, 5. Okay. So what will be our points right here? 8, 15, we have 7. Okay? What is the interval of 4 to 5? We have 1. So we could tell right away that it's 7. Rise over run is 7 over 1. So it's equals to 7. So we have the difference from 8 to 15. Or we could say 15 minus 8 equals over 5 minus 4. Doing the y2 minus y1, x2 minus x1. So we have 15 minus 8, then 5 minus 4. So that equates you to 7 over 1. It's giving you 7. Do the same thing when you have 5, interval of 5 to 6. Okay? So that means we'll get the, how much is the value when it's 5? That's 5 squared minus 2 times 5. That is 25 minus 10. You have 15. When at 6, so you have 6 squared minus 2 times 6. You have 36 minus 12. Then you have 24. By doing this, you could say 24 minus 15, then 6 minus 5. That is y2 minus y1. This is your y2, this is your y1, then x2, this is x2, and that's x1. Okay? So 24 minus 15, that's 9. Alright? Over 1, and that is equals to 9. So the average rate of change is 9. So what can we say about the average rate of change for a quadratic function? Because it does not stay the same. So for consecutive equal length input value intervals, the rate of change of the average rate of change of quadratic function is constant. You see this right here. I go back to the graph. Right here. Right here. It is constant. Compared to the linear function, the rate of change of the average rate of change in the equal length interval is 0. But in quadratic, it is constant by getting the second rate of change. Okay? Second difference, I mean. All right. Let's do this. Okay? Let's have a practice. What is the average rate of change for each g function on the given intervals? Okay. The function given is y equals x squared plus 4x minus 2 on between negative 3 to 2 or negative 3 to 2. That's your interval. Okay? So you could, I could start using here, y sub 2. I could have 2 squared, substitute it to the function, 4 times 2 minus 2. That would be equals to 2 squared is 4 plus 8 minus 2 is giving you 10. Right? When the y of 3, okay, the function of 3. Let's substitute 3 in the function, 3 squared plus 4 times 3 minus 2. So you have 9. 3 squared is 9 plus, it's negative 3. Sorry for that. So this is negative 3. 4 times negative 3. So this is minus 12 minus 2. Okay? So that would be equals to 9 minus 14. That would be equals to negative 5. Okay. Let's do the using the formula y2 minus y1. Okay? So I could have 10. This could be the y2. This is the y1. This is the x2. And this is the x1. All right? So I have it as 10 minus a negative 5 over 2 minus a negative 3. So 10 plus 5, okay, 10 plus 5 is 15 over 2 plus 3 is equals to 5. All right, and the value is 3. Okay. That is the average rate of change with the given intervals. Right? So just follow the process, the routine, no? First of all, you have to substitute the value of the given intervals in the function. Then after that, use the formula for finding the rate of change. This is the rate of change. Actually, that's the slope. All right. Let's do this. Our interval is 2 to 5. That means this is our x1 and that's x2. So y of 2, that is 2 times 2 to the power of 2, 2 times 2 plus 1. So 2 times 2 times 4, 2 squared is 4 times 2, that's 8, plus 4 plus 1, that's equals to 13. Okay? Let's have y when y is 5. Y to the 5th, that's 2 times 5 squared plus 2 times 5 plus 1. So that would be 5 squared is 25 times 2, that's 50. 2 times 5, that's 10. Plus 1, you have 61. Okay. Let's do the change of slope. So this will be your y sub 2, and this is y sub 1. So you have 61 minus 13, then you have 5 minus 2. So that would be 48. 61 minus 13, that's 48. Divided by 3, you have 16. Okay? All right. You got it. Let's do another type of problem regarding the quadratic function. For each problem of a quadratic function, g has the given average rates of change on an interval. Okay? What is the interval here? It says at first, the average rate of change is 1. Okay, I'm going to write it here. 1 when the interval is I'll do it this way. When the interval is 3 to 0, the rate of change is 1. The average rate of change in the interval of 0 to 3, the rate of change is 5. All right. So the question here, what is the rate of change of g in the interval of -3 to 6? -3 to 6. So what's the interval of from here to here? Because you have -3 to 6 on that interval right there. I want you to look at that part right there. Oh, it's not -3 to 6. Sorry for that. Because I was looking at the -3. It's supposed to be 3 to 6. Okay? So the question here, what is the interval from 3 to 6. Look at this. It increased by 3. It increased by 3. This is also increased by 3, increased by 3. That means if the interval from 1 to 5, it's 4. That means 5 plus 4, the interval should be, the rate of change should be 9. Okay? By just looking at it, because you can tell that the difference from 1 to 5, that's 4. So that means from 5 to 4, that should be 9 because they have an equal intervals, which is the equal interval here is 3. Okay? We could say that the average rate of change of the function is, constant. All right. For the equal length interval. So our interval has an equal length of 3. All right, let's do another one. The average rate of change on the interval of -1 to 5. The average rate of change is -1. Okay? What is next? When it's 5 to 9, the average rate of change is -7. What is the average rate of change from 17 to 21? Okay? So, let's look at what's the interval here. 5 to 9, that is 4, right? What's the interval here? 1 to 5, that's also 4. How about we add 4? 5 to 4, that's 9. 9 to 4 intervals, that's 13. Then 9 plus 4, that's 13. 13 plus 4, that's 17. And then 13 plus 4, that is 17. 17 plus 4, that's 21. So this is increasing by 4. And the interval here is by 4. So we have the interval. And this is the increase of the rate of change. So let's look at -1 and -7. From -1, then it becomes not -7. So we reach here 17. We stop because this is where the question is. So -1, then is it reducing or decreasing from -1 to -7? It decreased, right? It decreased by 6. So if you add 6, -6, you have -7. So how about another 6? 6, that's -13. Then -19, right? Then another 6, you have -25. So in other words, the interval of 17 to 21 is equals to -25. We're just looking at, the pattern. and looking at the difference. Okay, until you come up with a constant difference. All right, let's do question number 3. What is the rate of change? What is the rate of change of the average rate of change for the given function over consecutive equal length? So in this problem right here, we know that the rate of change of the average rate of change is constant. We know that, but we have to find a way how we're going to do it. Okay. You have the function of x squared plus 3x plus 8. How about if I assign, because since there is no interval given, I will just assign an input values and check what will happen. Okay, let's do this. If I use a -3, say -4, -5, I think 3 is enough. Okay. You can assign any values you like, input values you like, and try to check if, the rate of change or the average rate of change for the given consecutive equal length. So I'm using the length -3 to -4, that's 1. -4 to -5, that's 1. Okay. I will substitute -3 to the function. Plus 3 times -3 plus 8. So -3 squared, that's 9. 3 minus 3, that is 9. Then plus 8. So you have the value of 8. Right? I'll have -4 squared plus 3 times -4 plus 8. -4 squared, that's 16. Minus 3 times 4, that's -12, plus 8. 16 minus 12, that's 4, plus 8, that's 12. Okay? F of -5. Let's say -5 squared plus 3 times -5 plus 8. So I have 25 minus 15 plus 8. I have 18. Okay. I want to add more. I want to see how it goes. How about -6? So -6 squared plus 3 times -6 plus 8. So I have 36 minus 18 plus 8. 36 minus 18 plus 8, I will have 26. Alright? I think so. 36 minus 18 plus 8. That would be, alright. So, let's get the difference from 8 to 12. We add 4. Right? Then 12 to 18, we add 6. 18 to 18 to 26. How much do we have? We add 8. Right? That's the first interval. So we get the second interval. This is the first difference. It's a non-constant. So we get the second difference. 4 to 6, we add 2. 6 to 8, we add 2. This is the second difference. Take note, we are asked to get the rate of change of the average rate of change. So in other words, this is our rate of change. So we could say that the rate of change is changing by how much? Changing by 2. Okay? It's changing by 2. Be sure, if you are given something like this, you have to get the first difference, then the second difference. Okay, let's do this. The values of function are given at selected values, x values, in the table below. So the function concavity does not change. Determine if the function is concave up or concave down and justify your answer. Okay. If you are given a table, first of all, look at your interval. 4 to 7, you have an interval of 3. 7 to 10, you have an interval of 3. 10 to 13, you have an interval of 3. Okay? Then, for the y values, g of x, get the first difference. So you have 20 minus 35, that's negative 15. Then 13 minus 20, that's negative 7. Then 10 minus 13, that's negative 3. This is your first difference. Okay. So, what can you say about it? 15, negative 3, negative 7, negative 3. Is it increasing or decreasing? By just looking at it, you will know right away that this is increasing. From negative 15, negative 7, negative 3, as we move on closer to 0, that means the rate of change is increasing over the equal length input interval. Okay? So I would say this is, if it's increasing, it's concave up. Okay? Give you a reason, because the rate of change, I'm just looking at the first difference. The rate of change is increasing over the equal, it says here, equal length. What's the length? Input. Length of the input value. X value in the interval. That's it. 15 increased to negative 7, then to negative 3. So it is concave up. How about the last table? Let's look at this. All right. So let's look at the interval. It's negative 12, negative 7. Are they equally intervaled? you add 5, 12, 7, 8, 9, 10. Okay, 5 by 5. This is also 5, 2 to 7, negative 2 to 3, it's 5. 3 to 8, that is also 5. So they are equally intervaled. Then let's look at the difference. So the difference is negative 12 minus negative 10. You have negative 12 plus 10. You have a negative 2. Do the same thing. Negative 16 minus negative 12. So negative 16 plus 12. You have negative 4. Then negative 22 minus negative 16. That's negative 22 plus 16. That would be negative 6. Then negative 32 minus a negative 22. So that is negative 32 plus 22. It is negative 10. Okay. What have you observed from negative 2 to negative 10? Increasing, decreasing. This is decreasing, right? As the value of the negative moves farther away from 0, the value is decreasing. Like this is increasing. For a negative value that moves closer to 0, then it is increasing. Okay? So that means if this is decreasing, this is concave down. Okay? What's your reason? You could say because of the rate of change. What can you say about rate of change? Is decreasing. Over the equal length input. Input is the x value. Value interval. That's it. It's how you reason up. By looking at the table, we have that. By looking at the graph, we have that. By finding the rate of change of the average rate of change, we have that. So I hope you were able to understand and able to, that's why I'm doing it step by step, so that you can really understand what is going on in a quadratic function, in the rate of change of quadratic functions. Okay? Let me say this. If I can do it, so can you. Alright? Don't forget to hit the like button and hit the subscribe. Okay, in my next video, I will be doing more problems and solutions on the rates of change in linear equation and linear functions and quadratic functions. See you.